first, and then as we get into inferential, we'll work with the parameters. In statistics, you're going to know what the letters are. They're going to be X's and Y's and T's and that kind of stuff. And these will describe the data or scores. Sometimes it may be a sample, not quite there yet, but sometimes it might be a sample. And the parameters will describe populations. And they're going to use Greek letters. So an example of statistic we'll be doing really soon is a mean or an average, is X bar. Some books also put it as a capital M because it's easier to type. So now you're seeing capital M used a lot. So this would be a mean or an average of a group that we have. So for instance, I could look at your surveys that you gave me and get an average age. Remember the surveys you did for me first week? I could add those up and get an average age. Easy enough. I get an average number of courses you're taking. Get some demographics from you, and we would symbolize it with this. We're going to use X bar. Our book uses X bar, so we'll do that. But if you see an M many times, that's what it means. The Greek letter for that, the equivalent to that as a parameter, is a mu. Kind of a fancy looking M. It looks like this. That's a mu, and that's a Greek letter. So this then is the population mean. So anytime you're seeing a Greek letter, it's referring to the full population. You're going to know the whole Greek alphabet by the time we're done. If you're looking for these on your computer and you're in Microsoft Word, it's under symbols. Find the Greek letters there. They look a little bit different depending on the font that I'm using when I type them. But if you ever have a question about whether or not that's a mu in something I've typed, just ask me. I try to be bold or make sure that you can see that that's what it is. Of all kinds of these. So the next time you're near UCLA or they have them in Cal Poly, they have them in Cal State Fullerton, where they have fraternity and sorority houses, you know, where the people live, they'll have the Greek letters on the outside of the buildings. You're going to look really smart now. Oh, there's the Alpha Gamma Sigma house. You're like, oh, you know what that is? Yes, I do. So you're going to read a lot of them. So they show up a lot in mathematics. But just remember, parameters, population. Those will always denote the population. And I'll always call your attention to. Oh, let me show you this stuff. This shows you some of them. Just so you know that's in the PowerPoints too. So yeah, we have alphas and betas and gammas and deltas and sigmas, all kinds of stuff. So what we want to look at next is kind of our next little piece of statistics is characteristics of scores and ways to categorize them. So you have one handout, we actually have two tonight. The first one is scales of measurement, or measurement scales, they mean the same thing. Only refer to these things. So on the test, when I say, tell me the scales of measurement, this is what I'm talking about. Okay? There's 4 of them. There's nominal, ordinal, interval, and ratio. This goes from kind of worst to best as far as statistics is concerned. Kind of lowest to highest order, think it that way. And I'll give you the quick and easy way to remember these, then we can look at the handouts. But nominal means name. So nom, think of name. It's name only. The name doesn't mean anything. It's just a name. So there's no order implied by that name. There is no amount implied by that name. Just a name. So my mother made up my name. What's the name? Meaningful to her. It was her mother's first name and her middle name. So she came up with Vera Jean. I drove one of those names that was never on anything. Some kids got the little license plates with their names on them. Door things, never mind. I always said that was custom name. So the idea is it's just a name. Now, if you're Richard the First, Richard the Second, Richard the Third, that's different, right? Because it applies in order. So then that wouldn't be a nominal scale. So nominal means a name only. So those sports fans among you are the letters or the numbers on baseball players' jerseys. Do they mean anything? Just a name, right? It's a number they pick. It's usually what they have in Little League. And then they want that number forever and ever. They're very superstitious. The most superstitious athletes you'll ever meet are baseball players, especially pitchers. They do all kinds of weird things. Ask them about their superstition. And so those are name one. What about football players? Numbers. Those have some indication of meaning. Because you have, for instance, lower numbers will usually be the quarterback's number. And then the big numbers are the lineman's numbers. And the running joke is the lineman's name because that's who they fit on. The 88 fits on the back of a lineman. Those little tiny quarterbacks get a 7. That's the idea. So it's like the bigger numbers go on the bigger guys. So usually if they have a higher number, it means they're on the line. Lower numbers could mean quarterbacks or backs. The idea. Not necessarily, not always, it's not a rule, but it's usual. We would indicate that. If somebody says, I'm 22, a number 22, chances are they're not a lineman. The idea is to be a running back or something like that. So that's how you kind of look at it. Does it have any further meaning? Then we go to ordinal. So now this has to do with order. And it says it right there in it. So think this is always some kind of order. This can be first place, second place, third place. It can mean ABC, like alphabetical order. It can mean I'm first in line, second in line, third in line. But there's no indication of spacing in the order or how far apart they are. Haven't you ever heard people say, well, there was first place and second place, and then there was that distant third? So like the distance between first and second is 1, then the third's way down here. See the idea? Or you may say, I graduated first in my class, my friend graduated second in their class, and Bob over here was third in the class. You know, and you're like, whoa, that's pretty good. You know, first, second, third, that's good. And how many people graduate your class? 3. You know, so there's no indication of who was where, is the idea. Just the order. And also, a lot of times you'll hear in regard to this, they'll use the word rank. So they'll say things like rank order, something like that. So we think of something like ranks in the military. It's kind of the idea. But if you also hear this rank order, that means put them in some kind of order, first to last, is what rank usually means. So that's pretty clear? The idea, so we've got name, we've got order. Now we get into the higher orders of these. And what we're looking at interval and ratio is what we normally use in statistics. They're a little bit higher order numbers. So this has to do with, they have equal intervals. That's interval. It has equal intervals, meaning equal spaces between the numbers. So we'll say equal space values. And then we also have, with this one, it can go negative with interval. Meaning 0 is just a placeholder on the number line. So we start out with positive numbers, we hit 0, then we go to negative numbers. So when we get to ratio then, same thing, equal intervals. It shares this with interval. Equal intervals, However, this has an O in it. See the O there? So that helps you remember that the ratio 0 is nothing. Nada, nothing there. Okay? It's empty. It's what we call an absolute 0. So that it can't go negative. 0 means absence. We're done. You know, it ends at 0. So now I will end up, and there's lots of them on the example, on the handouts, we didn't talk about this, where I want you to define these, and I'm going to want examples of them. Just so you know. So now you have to think about how much do you need to tell me in an example. So now I'll say, give me an example of an interval scale. And you might say temperature. It's going to be wrong because you haven't told me what kind of temperature. You have to tell me because there's 2 temperature scales that are interval and 1 temperature scale that is ratio. And say you haven't qualified it enough. Remember, you're always trying to convince me you know what you're talking about. So I'm assuming if you don't write much, that's my first clue. You don't know what you're talking about. It's better to write more when you don't know what you're talking about. Because a lot of times I've had students just guess and say, I don't know what it is. Just write something. Just give it your best shot. And they'll be right. But they're second guessing themselves so much or they're nervous, they don't realize it. So an interval scale would be Fahrenheit or a Celsius scale, right? Because they can go negative. Just ask the people in Montana. It's about negative. Last week they were interviewing us negative 20. They go, oh, you know, next week's supposed to be negative 30. Like, we don't care. Once we're at negative 20, we really don't care. You know, it's like we don't feel any different. We're all frozen. You know, negative 20, negative 40. And so that would be an interval scale. Ratio is a Kelvin scale. It's Kelvin. And it is a temperature scale. It's used a lot in chemistry. And it ends at 0. Can't go negative. So that's why you got to kind of qualify it. What about money?
In the bank.
Yeah.
The ratio or intervals? Money. What do you think? Interval how?
Because your account goes in, you can owe money to the bank.
It would be in a bank.
Yeah.
So if you said money, you're not going to be right. If you said money in the bank, does that make sense? I'd go negative. It doesn't have to anybody in here, I'm sure. But we've heard of people that this happened.
So in a way you could say that physical money is the ratio because you can't have like a negative $1.
Well, we usually say there's money in your hand.
Like money that
Money that you actually, yeah, we'd actually have in your hand.
and then interval is like
Money in the bank. Fake money. Money, yeah, electronic money. Okay. You can go up and down all day. The ratio money would be money in your hand, money in your pocket. The idea? I know it feels like many times you have negative money in your pocket, but it's really a physical thing. So it would be ratio because it stops at 0. If I have no money, I have 0 money. Does that make sense? So you have to think of when it gets to 0, does it mean absence of that? So what's weight? Like your weight. Your ratio scale, right? You can't have negative weight. Trust me, I've tried this. You can't have negative weight, all right? You have 0, you're weightless. It's the idea of 0 gravitational pull. The idea is to float. It'd be 0 gravity. 0 weight is like 0 gravity. All right? So that's kind of the idea of thinking of these. Okay, let's look at handout, the measurement scale handout number 2. I like this handout. I kind of adapted it from one I found on the internet and then added in some things. And what I really liked about this was the picture. It kind of shows you what I had. The equal intervals without absolute 0 with the absolute. Just give you a visual of it. I thought it was nice. And the idea of lowest to highest as far as level of number you're looking at. And then the other thing I like is it has a mnemonic. This is how you spell mnemonic, right there on the handout, right there. It's a weird spelling, it's an M and it's a great Scrabble word. All right, that's mnemonics. Mnemonics are memory devices. And this is one that I really like for these scales. NOR and no oil in rivers. Is the idea. Because what I found happening with students is they can get that, they get, okay, we got nominal, we got interval ratio, there's one with an O. You know, so sometimes if you have this, and you study it that way, it'll really help you. But you can't write this on your formula sheet. Just so you know.
Isn't that noir?
It can be either way. If you're French, it's noir. You know? If you're just, you know, stupid American, it's noir. Noir, I like much better. Okay, so sometimes those will help you, especially when you have to memorize kind of like a scale that way. All right, so flip it over. Now we have this exercise. And I want you to do this now. First one, these are first three. First one is their name of the country they're born in. No? Yep. Okay, good. And then the two scales that have equal distances. That's it, the equal interval and equal distances, right? Look those, interval and ratio. And then here's where I want to show you where they use the word rank. So it says, we have a teacher rank students according to their oral language skills. Right, you see the idea? That's what they mean by rank. Okay, you speak the best Spanish, do the next best, do the next best. That's a rank ordering.
The word rank, is that kind of like anywhere like you should know that or no
Yeah, that's really what ranking means. Rank means put them in some kind of order. Now, it can mean rank order them by language skills, rank order them by grades, rank order them by height. So it's a word that's always indicating some kind of order. Yeah. And it's the same way that I could do ranks in the military. We know a general is way above a private. See the idea? That's the idea of ranks. It's used the same thing. Let's see. 4, 5, and 6. So 4 is absolute 0. So which one's that? Ratio scale, right? Remember 0 has a 0 in it. Number 5, lowest level, meaning like the one least useful to us really in statistics is nominal. And then number 6 is ratio. And this is probably the trickiest one on there. It says objective multiple choice achievement tests are usually measured at what level? Meaning ratio, meaning you either have 0 right or you have a lot of them right. And most questions are like 1 point. Right? So it's like 1, 2, 3, 4, 5, so you're counting up the score. But usually multiple choice ones, within a multiple choice question, you have A, B, C, and D, and each one of those answers, the right answer would be 1, the other 3 are wrong. You see the idea? That's how most of them are set up. I've had multiple choice tests that are not set up that way, where, and a stat professor did this. There was the best answer, and you got 4 points for that. The next best answer was 3. The next best answer was 2. And if you picked the 4th worst answer, I guess, then you got 0 points.
It was like the exams. That was just, they were like, oh no, you're trying to look for the best answer. 'cause
The
they're
best
all
answer, I
right,
know.
So look for the best answer.
I know. It's kind of either a right, no, there can be a second best answer. I'm like, what? That's my worst guess or my next best guess? I know. What does that really mean? So that's just considered a ratio scale. I would not have one like that on the exam. You see what I mean? It's kind of like, I don't know what she means, you know? So I try not to put those on the exam. And here's the rest of them. So 7, the idea of most honest, next most honest, so that's a ranking. That's why it's ordinal. Then number 8, minutes of overtime work. Does that make sense why that's a ratio scale?
You can't have negative.
You can't have negative overtime. So the way I do this in my own head, just so you know, is when I'm asking, I have this and say, okay, what scale is this? Like on the chart, my first question is, does it have a number on it? Are the numbers in order? Or are they on some scale? Because then I know it's either this or this. Then my next question is, can it go negative? I only ask myself those two questions ever. Does it have a scale? Yes or no? Then I kind of know which batch I'm in, and can it go negative? That way I'm not having to remember every little bit about everything, and that kind of tells me which way to go. So then number 9, the weight measured in pounds. Right, has to be ratio, can't have a negative weight. Right, now number 10, these are demographic data that has just a nominal measurement. Meaning it can't be your age, because that indicates some kind of order, right? So these could be things, I just put some examples up here. Religious affiliation, hair color, sexual orientation, marital status.
Could you say like asking somebody what their favorite book is normal?
Yes, that'd be fine. Favorite book, even ethnicity would be fine. What else you got? What? Country of residence would be fine. Gender's fine. Yep. Where were you born would be fine. Yep.
What city you live in?
What city you live in. And I have just a name.
Just name it and tell me number.
Right, just doesn't even have a number attached. You've got to be really careful about some areas like what's your address? Well, can your address indicate something, like a street number? You see what I mean? I'm in apartment 2B. Is that better than 2A? Like that. You have to be a little careful whenever there's numbers. It may or may not mean something.
What about foot size?
Foot size? Foot size could mean, it's not, just reporting shoe size. I think you'd be okay with that even though it is a number. Yeah, but if you're not asking you, do you have a large size foot? Yeah. You're just asking shoe size, yeah, that'd be fine. Age indicates an order. Age is always like an ordinal scale, but this is a tricky one with age. It's an ordinal scale for the most part, but it also is interval and ratio, depending on who you talk to. That's why I never have to do about age. So when we actually legally start counting your age, with the day you're born, you're 0, right? And you go to what your first year is your first birthday. So your age is always at the end of the year of life. You see the idea? So we say 0, and then you ask, well, can you have negative age? We don't count negative age anywhere. But are you technically, this becomes the tricky question, are you technically alive before age 0? Well, we don't say, okay, at your first birthday is 1 year and 9 months. You see the idea? So it gets kind of tricky though when you're talking about it as a scale. So a lot of times I just don't use it as an example of anything. As far as scale, but we can add and divide them. We can get it, so if you said it would make sense for the equal intervals for you to say, well, I'm 26.2 years. That's an actual age. You see the idea? That wouldn't be weird to divide it up. You can figure that out. So it's one of those that's really on the cusp of a lot of them, depending on how we're using it. All that. So you just gotta, if you're gonna use it, you have to qualify for it. Now you see why it takes me so long to grade the test. So I have these kinds of questions. Because everybody will come up with all these different answers. I just think about them in a minute. They're not all just number answers. And then the last one, 11, is interval. An elevation. Because we have sea level is 0. Can you go below sea level?
Yes.
Yes. They use that one a lot. Yes. And that Fahrenheit temperature to go negative. Usually one. And these are the ones in the scale, in the chart. See if you got those okay. Okay. The college degree is ordinal. They go in order of how they're obtained. So you have like AA, BA, bachelor's degree, master's degree, PhD. So it's assumed you've been in school longer if you have a PhD than if you have a bachelor's degree.
But what if you take it as if they're asking you if you have any college degrees? You can have 0 college degrees or more, and then it would be, wouldn't it be like ratio? 0 or more?
No, it can't be ratio because we can't divide it up. Like you can't chop, so always think of it too, and I'll show you discrete continuous. you can't really chop up a college degree. You can't say I have a BA and a 4. You see what I mean? So that's what, usually I do that in my head to make sure it takes it out of ratio interval. But it could be nominal.
I have one
And
right
that's
now.
why I have to qualify like the ones on money, like on F and G, money in your hand or money in the bank. Or heat and centigrade. See the idea? So that's why. Now the hats, shoes, pants, and socks, do you have to think about order for a second? Do I put those on that way? It doesn't make logical sense to do that. So, you know, and there are skills that can be either. So there's sometimes I'll give you examples and I would take either answer depending on how you explain it. A discrete scale are going to be our nominal and ordinal scales, meaning they're in whole units. So a discrete scale is how many children do you have? I have 3, I have 2. You see the idea? How many animals do you have? How many pets do you have? Well, I have 5. Or I have 1. So it's a whole number. Now, many times what they'll do in statistics is they'll take a discrete scale and make it continuous, which means they're using the statistic improperly. So you'll hear these things like, the average family has 2.5 children. I've never met the 0.5 child. You know, it's kind of like, there really isn't a 0.5 child. Or it will be, you know what the average number of TVs is in the United States? Per family. Way higher than that.
5.3.
Yeah, it's like 5.2. You know, so I know, I was floored by that. You know, so like 5 TVs is a little, I don't know. And what's the 0.2? The broken one in the den? You know, the broken one in the basement, you know, kind of. So it's really a proper use of statistics, but you're trying to get it a more exact average instead of rounding it to a whole. That's the idea. And then continuous scales are ones that have these intervals, and the intervals can be made smaller and smaller and smaller. In essence, you keep chopping it smaller and smaller. So as you're watching the Winter Olympics, and they're giving you like the time down the skiers, down the slope, you ever notice how the numbers after the decimal point, you know, just keep getting longer? Like they're able to chop it smaller and smaller bits to get it to exactly 1. And what a lot of them are using now is a laser beam. And so there's a laser that goes across, and then as soon as something breaks into that laser, it gets the time. You know, so they're getting that exact. So you were a winner by 0.10 of a second. You know, I was like, really? Yeah. And then they did this with the swimmers at first, where I don't know if you noticed, they showed you the underwater shot where the swimmers reach out, and as soon as the tip of their hands, you know, hit the underwater thing. Well, swimmers are smart. They're making their nails longer. You know, they actually have rules now where they can't use fake nails. You know, and they have certain lengths. They're not like allowed that. So I imagine I'd be that freestyle swimmer. 10-inch nails. What's wrong with that? I always win. You know, so diving in. You know. So that's the idea. They're using. You'll see a lot of continuous scale in the Olympics. But there's a discrete scale for how they give out the medals, right? First, second, third. That's it. And those are kind of seen as equal, even though their scores might not be. You see what I mean? You're just third place. You could have been the distant thirds ice skater. You could have been the one that fell every time. But if you're in third place, okay, you get the bronze medal. You see what I mean? You're just hoping more people fell than you did in order for you to get third. So that's how they're ranking it in that order of the score. So that would be seen as they don't have any like silver and a half medal. You see the idea? No, doesn't work that way. I think, I'm not sure, but if they have like 2 people score exactly, do they give out like a gold and 2 silver thing? I was gonna look that up. I meant to look that up on Google last night to see what happens if like second and third are exactly the same. You wonder how they break those ties. There's some sports that really happen, you know. So I'll have to look at that. See, where did we ask these questions before Google? Yeah, okay. All right. So that's discrete continuous scale. The next thing we're going to do is rounding. Now I know you think you know how to round. Most of you do. We're going to change the rules a little bit. So I gave you a handout on rounding. So with rounding, you have that handout tonight, yes? Okay. So for the most part with to round to the thousandths place. And that is usually in regard to a final answer. Much of your work you're going to have to show me on the pages. But let's say you are going to do an average, and you have 20 numbers to add. Do you need to write across the page 20 plus 10 plus 1? No. You just would enter those into your calculator and then give me the final answer. You see the idea? So as we go through those, I'll show you what I'm expecting in your answer. But if your final answers where a decimal is involved and it goes beyond the thousandths place, and I'm giving you examples of how far those go past the decimal, I want you to round it up to the thousandths place, but never less than that. Okay? If it has less than that, like there's zeros there, that's fine. You're not going to put the zeros. But if it has something after that, you're going to need to put it. All right? So there's different ways in which people have been taught to round. And I'm going to show you the way that most people have been taught. We'll look at 2A there. And so we have the example of 45, this is A, 45.677455. I'm telling you to round to this thousandths place, which is the third one to the right of the decimal, so that's this one. So then usually the easiest way to do this is to look at this remainder as a whole number. Some people were taught to round each number, like round this one to round this one to round this one. Not many people are taught that way anymore. Way back in the day, like I'm an abacus or something, but some people were taught that. So what we're going to do is look at, this is probably how you were taught to round. You look at this number, and so where do you think this number would round to? It would probably just stay the same, right? So really how you're looking at this is think of this as 500, and you're asking yourself, is it below or above that? If it's below that, if it's below this number, it's pretty much going to stay the same. You just take off that remainder.
I would round up
Why?
because the 4.5.
But that's you rounding each number.
Oh,
Do you see what I mean? That's like taking this 5 to round this one, and then to round this one. And some people are taught to round that way. That's what I was taught to round initially, yeah. Yeah. Yeah, that's one. You'd be rounding each number. So the way we're going to do it is you're going to look at anything that's a remainder, put a box around it. You can do this mentally or you can actually write it. It doesn't matter to me. It's not something I have to see. And then our question is, you put a 5 in however many zeros you need, and ask yourself, is it above or below that? If it's below that, it's going to stay the same. That's what we used to call that rounding down, right? You would just leave it the same.
So I always have this problem before. For the 455, you always go to the next number above and put like 500.
No, this one stays, so this one, you always go to where like half is, all right, the 500. So this one, because it's less than that, it stays the same. Okay? So let's look at B. And I'll give you more of these if you need them. And 45.677 533. Same thing, we're going to thousands. Now we're going to look at this. Same question. Is it above or below? So what's this one?
Above.
It's above, so what are we going to do?
Okay, the 7 turns into an 8.
We're going to round it up. Right? We have more than half, so we're going to round up. So we have 45.678. Now this would also be the case, I'll do another one like this. Let's say I have 20.122, and I want to go to here. Okay? Same thing looking at that. Let's put some other numbers in here. Let's say I have a longer number. It's still the same thing. Just slap a 5 there. However many zeros you need as placeholders, and ask yourself, is the number in the box higher than that or lower than that? Lower. It's lower, so it's going to stay the same. Okay? It doesn't matter how many numbers there are.
So when we do our answer, even though we can round in our head, we want us to show all.
No, you just round your head. You don't have to show me this. It's just, some people need to do this initially to kind of get the rounding thing in their head. But you don't have to show me that. I'll know what you did. Psychic power. As you can tell. A lot of times that's what takes me a long time to grade your test, because I'm redoing your math to see how you got what you got. And once I can figure it out, I'll know what you did. You know, then I can kind of know, give you partial points or full points, that kind of stuff. Okay, so then these were pretty much the same. So let's say if I had 20.126, something like that. I'm looking at this number. Same thing, I just want to box everything that comes after the place I'm going to, which for us is going to be the thousandth place. And if you need to, you just kind of write in all this, and you're asking yourself, is it above that number or below that number? So it's above, so what's this going to go to? It's going to go, that 6 is going to go up to a 7, and a round up. Now, most of you have rounded this way before. Nothing new about moving up and going down or remaining the same. Now, the hard part is what happens when it's just a 5. So here's the quirky changes on the back of the handout. So what happens, most of you were probably taught that if it was a 5, you rounded up. Am I correct?
Yes.
Well, what that does is that inflates all your numbers. You see the idea? It's inflating it too much. You don't have enough numbers under that. So what we have to do is balance that. Because in statistics, if we keep inflating the numbers, bad things happen. We put drugs on the market. Oh, gee, it killed more people than we thought. You know, we just rounded up. You know, so you got to be a little more careful with statistics. It's got to be more balanced. So what we want to do is part of the time round down and part of the time round up. So this is the way they came up to do this. So look at your examples there on C. We have 45.6775 and nothing else. I'm going to here. Now I have this. So now I write my number on there, and I'm going, is it lower or higher? You're like, oh, darn. Here's that 1 that she said was going to be different. What do I do now? Well, now, whenever it's 5 and nothing else, right? It's 5 and no remainder. There's no 1 down there, there's no nothing. Now we have to have a rule for sometimes going up and sometimes going down. So if this is an odd number, so you have to know evens and odds. Yeah, right? And 0 is an even number in the scheme of numbers. Okay? So 0 is even, just so you know that. So now, this is a 5. I look at the number that I'm rounding to. That's an odd number. I need to make it even. We go up to the nearest even number. So this becomes 45.678. Now, you probably would have done that anyway. Right? Not knowing why you did it. Because you don't even top to round 5 up. It's the other ones that get people. All right. So now let's look at 45.6445500. Again, we're going to go to the thousands. And look at this. Oh, here's that special rule again. Here I have just the 5 and nothing else. So now most of you would think to round up here. That's what you can't do, because that's what's inflating the number too much. You can't just keep rounding up. So now you look at this. This is an even number. Right? Last time we looked for is an even number. It stays a 4. So anytime, here's the clincher, so you know you're doing it right. Anytime it ends in 5 and nothing, your answer better end an even number. Or you've done something wrong. Okay? Whether you're going up or down, it's even. So now this would be 45.644. And that's what I tell you on here. If it's an odd number in front of it, we round up to the nearest even number, so our answer is even. If it already is an even number, we keep that number as is. There was like us. No problem here. Oh yeah, it will be. On the exam, you'll forget it. And just keep rounding them off. That's a good idea. So you just have to stop a second whenever you're rounding, and it's not just a 5. You're going to be fine. It's when it's just a 5, things change. Go ahead.
So if it's odd, it goes up to the next even number,
Correct. You go up.
and if it's even, it stays the same.
Stays the same. Exactly that. So if it's odd, it goes up to the nearest even number. If it's already even, it stays the same.
For the not weird ones, the early ones,
Uh-huh.
could you just look at the next number over?
No. You really need to look at this as a whole number. You really do. I know it feels like you can do that. I think you should look at it as a whole number. Just to be in the practice of that.
Yeah.
Most of the time, you're saying more.
No, yeah, that's just the way
I
I.
know.
Would you get it wrong?
Most of the time, not. But sometimes what ends up being weird is it throws people. Uh-huh.
Okay, just to make sure, say on like the 45.644500, say it was 6.644552.
Okay.
So is
You're right.
that so the original thing we were running on prior or different one?
0.64452. Is that what you said?
Or like 552, no, this is about, say there's something after the 5.
Yeah, 552 like that. Here, you tell me how it would happen.
It's more like 500, so
Goes up.
Goes up.
Right.
It's just the 500.
It's just the 500. So what they're asking me here in front is, can I just look at this number and be able to tell what it does? Most of the time, yes. But if it's a 5, that's what messes you up, because what if it's this? You have to look at all of them. Right. So the way that most of the time we're taught this instead is just for, so you don't have to think of like, okay, when it's this, it's this. You just look at it as a whole all the time. But if you're in your head, what you're saying is correct. As long as it's not a 5, yes, you can do that. Did you come up green?
That's just the way I do it.
I know, me too. Sorry.
So for this one, when she just said, it would become 45.645?
Yes,
Okay.
this would become 45.645. Does that make sense? Because there's something after the 5, so it needs to go up. Uh-huh.
If the number to be rounded up is a 9, do you make it a 0 and go over before?
Yes, so we'll do one like that. It's a good question. Erase this one. So say we have 45.789,552. That what you mean, something like that? And so then we're going here and we're looking at this. What's going to happen here? It's going to go up, right? And so we're going to have 45.790. The 89 goes to 90. That part doesn't change. That part was the same. Yeah.
What if the 8 was a 9 with the same thing?
Uh-huh. We write it out. So we have 45.799. Feel like I'm on Jeopardy now. Okay, what do you think? What do you think? 45.800, right? The whole thing kicks up. This has got to go up. Once it goes up, 799 goes to 800. See the idea? So that's sometimes we got to kind of not look at it as each number and kind of look at it as a whole number. And kind of say, okay, if I went up one more, what number would I have? That's the idea.
Now let's say that 552 on the last one that you did is a 500.
Okay.
Still would go up because you have to change the 9 to an even number.
What do you think?
Well, you have an odd number. The 9's an
That's
odd
right. You got a number, so you got to make it up to the next number, which is a 0.
Right.
It's going to be the same number. So you're going up literally to the next number. The idea.
Well, it's like all zeros and one.
Okay. So like all zeros after the decimal? Okay. So here, 45.000 like this. 5, and then say 500. So now we're here.
Stays the same.
Stay the same, because zero's even already. Now, for the answer for this, do you have to write 45.000? No. That's what I'm saying. If you just want to say, if I said round this to thousands, what's the answer? And you just wrote 45, you're fine. You'll find I'm not that picky. I'm really not. You know, little stuff like that, it's just the last thing we have to worry about. All right? I'm going to assume you knew the zeros were there. Any other ones you want to test it with? All righty. See, I told you what happens in class. Your energy's doing this and mine's going like this. Right. Wide awake now. You're okay? All right, so let's try these that you have on here. Third one over, and we're looking here. So what's this one going to go up to? What's this number? Should be 6.6. All right, next one is 0.011. Now what?
It's gonna be 0.
Gotta make this a 2. Right? Because this has to be even in front of it. It's 5 and nothing else. So this is going to have to go to a 2. Alright, so we've got 9.89. Now I need to know what to do with this 5.
Bump it up to 1.
It's going to have to go up, because see that 1 there? See how that makes it above half? Now we have this one, we're going to here. I'm going to keep this one the same.
Yes.
And why?
Because it's even
It's
already.
already even. This one here.
It gets bumped up.
What do you do?
It gets bumped up to
It's
a
got to go up, because it's got that 1 way down here at the end. That is a remainder that makes it go up. And then what's the last one?
0.
Yep, just be a 0. You can write it as a 0 or a 0.00. That doesn't matter. Either way.